In this video, we are going to be looking at how to apply Newton's second law in multi-step calculations. To do these calculations, you're going to be using a standard problem-solving technique where you underline the key points, you make a list, and you use your data sheet to find the correct formula. You substitute the values to solve in that formula. You don't forget your units, and very importantly at the end you ask yourself, is this a scalar or a vector quantity? Because if it's a vector, you have to provide a direction. Let's look at our first example. Gemma was riding a bike, combined mass of 50 kilograms. So I'm going to write that down. 5 meters per second north. So the initial velocity is 5 meters per second north. If she applies a thrust force of 3 newtons and has a frictional force of 0.5 newtons, calculate her displacement if the force is applied for 1.5 minutes. Now I've got two forces. So because I've got two forces, I can do vector addition to find the net force, because we have a force of thrust, which is 3 newtons north, and we have a force of friction, which is 0.5 newtons, and friction is always in the opposite direction, so that will be south. We're going to calculate her displacement if the time period was 1.5 minutes. Now immediately there should be some alarm bells going off, ding, 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 because this is in minutes. And we always do our calculations in seconds, so we're going to times it by 60, which is 90 seconds. Now we've been asked to find a displacement. So I get my data sheet out and I look at how I can find a displacement. And I find that to find a displacement, I need to have a V average and a time. Well, I've got a time, but I don't have a V average. So that's no good to me. Now, to find a V average, I need to have an initial and a final velocity. Well, I don't have a final velocity, so that's not going to be very helpful. So I'm going to have to find a final velocity. Then I find, if I want to find a final velocity using my data sheet, I find that I have to have an initial velocity, an acceleration, and a time. Well, I've got an initial velocity, I've got a time, but I don't have an acceleration. So I'm going to have to find that. Now, to find an acceleration, I can use Newton's second law. Force equals mass times acceleration. Well, I've got two forces, so I can find a net force, and I've got a mass. So that's how I'm going to do it. I'm going to use Newton's second law as my start point. But first of all, I have to find my net force. So step number 1, I'm going to find the net force. Now I know that I had a force of thrust, which was 3 newtons north. I have a force of friction, which is 0.5 newtons south. So I need to find the resultant force. So force net is equal to the force of thrust, add the force of friction. So the force of thrust was 3 newtons north. We're going to add it to our force of friction, which is 0.5 newtons south. So it's got to have one direction here, negative 0.5 newtons north. So the net force is going to be 2.5 newtons north. Okay, step number 2. I can now use Newton's second law. Force equals mass times acceleration. Well, I've calculated my force is 2.5. The mass is 50, and we're going to find an acceleration. So rearranging this is equal to 2.5 divided by 50, which comes out to 0.05 meters per second. Step number 3. I've now got my acceleration. I can find my final velocity. So remember, we go to our data sheet and find the formula as V equals U plus AT. We've got the initial velocity is 5. the acceleration is 0.05 and the time was 90 seconds. So this comes out to be 9.5 meters per second. Okay, so now we've got the final velocity. Now what we have to do is find the average velocity. So step number 4, V average equals U plus V over 2. So the V average initial velocity was 5, the final velocity was 9.5 divided by 2, which comes out to 7.25 meters per second. Last step, we've got a V average, so now we can find a displacement. V average equals displacement divided by time. So the V average was 7.25. The displacement we don't know, but the time was 90. So rearranging that, displacement must equal 7.25 times 90, and it comes out to 652.5 meters. Now, our last step, remember, is to determine if this is a scalar or a vector, and we know that a displacement is a vector, so we have to give a direction. It is north. Now let's try another example. This time Naya's driving a car, mass 1500 kilograms. With an initial velocity of 25 meters per second. She then accelerates to a final velocity of 40 meters per second over a time period of 4 minutes. Remember, minutes are a problem. We have to convert it to seconds. So 4 times 60 is 240 seconds. Calculate the net force. Okay. So we've been asked to calculate a net force. So the first thing we're going to see is we're going to go to our data sheet and we look at Newton's second law, which says a force is equal to a mass times acceleration. Well, I've got a mass, but I don't have an acceleration. So I'm going to actually have to find that. Now to find an acceleration, if I look at my data sheet, it tells me acceleration is a final velocity minus initial velocity divided by time. Well, I've got a final velocity, I've got an initial velocity, and I've got a time. So I can actually calculate it this way. So part A, acceleration equals V take U over T. So final velocity is 40 minus 25 divided by 240. So our acceleration is going to come out to 0.0625 meters per second. So now, because we've got an acceleration, we can now find a force, which is equal to a mass times acceleration. The mass was 1500 times 0.0625 comes out to 93.75 newtons. Now I have to think, is a force a vector? Yes, it is. So I have to apply a direction. Now it doesn't give me a direction, so I'm either going to say forward or in the same direction. Okay, part B. Calculate the displacement. Now to find a displacement, we need a V average. And if I look at this, to calculate a V average, I need an initial and a final velocity, which I've actually got. So I'm going to go V average equals U plus V divided by 2. This is equal to 25, add 40, divide by 2, which is equal to 32.5 meters per second. Next step. If I've got a V average, I can find a displacement. So the V average is 32.5. The displacement we don't know, but the time was 240. So therefore the displacement must equal 32.5 times 240, which comes out to 7,800 metres. Don't forget your direction because displacement is a vector, so it's forward. It's important that you try some of these yourself. So go to your OneNote, Physics Unit 2, Newton's second law, and worksheet number 2 has lots of examples of this. Good luck.